Hello everyone, welcome to this lecture of the subject CAD/CAM. This is Mr. Suyog Patil, working as Assistant Professor in Department of Mechanical Engineering, Sharad Institute of Technology, College of Engineering at Rao, Ichalkarji. In this lecture, we are going to see the basics required CNC program. So first of all, we will see this introduction to this CNC machine. Okay. So this CNC indicates that the computer and numerically controlled machines, computerized and numerically controlled machines, CNC machine. This CNC machine is a numerical control machine which uses a dedicated computer as the machine control unit. Okay, in case of this numerical control machines, this MCU machine control unit, in this CNC machine, this computer is used to control this, or it is used to replace this MCU. Then this computer is used to perform the most of this basic numerical control machine functions. Okay. Then again it is defined as automation of machine tools operated by precisely programmed commands with computer is playing important role of this control. Okay. In this CNC machines, this computer is used to, or this computer is plays a important role of this role in this control of these functions or operations of these machines. Okay. So this again, these CNC machines are classified in these three groups. Okay, that is VMC, HMC, and UMC. Then according to this position of this machining center, CNC machines are classified into these three groups. That is vertical mill machining center, VMC, horizontal machining center, HMC, and universal machining center. If the machining center is vertical, spindle is vertically mounted, then it is called as vertical machining center. If it is horizontally mounted, then it is called as horizontal machining center, that is HMC, and similarly universal machining center, UMC. Okay, these are the three types of this CNC machines. Difficulties with this conventional system, or again we can say the difficulty with this numerically controlled system, NC machines. Okay, so these are the few difficulties, that is complex shapes are difficult to machine on this numerical control machines, or these numerical control machines are basically used for the simple jobs or simple operations. Okay, but these complex operations are difficult to handle on these conventional systems. Okay, so therefore CNC machines are used. Then again depends on the human skill. This conventional system or NC systems are depends on the human skills, as this manual part programming is used in these numerical control machines. So to perform these operations, this manual or skilled operator is required. Okay, so therefore it depends on this human skill. Then frequent and repeated measurements are required. Okay, on these numerical control machines, so manual measurements are required frequently, or repeated number of measurements are required. Then again it is difficult to achieve consistency in the product quality, as it is manually operated, so it is difficult to achieve this product quality consistently. Okay, consistent product quality is, it is difficult to achieve this. Then high changeover time, if this job changeover time or this tool changeover time is higher in case of these conventional systems. Okay. Then again less productive hours, then more scrap is generated with the help of with these conventional systems or numerical control systems. Okay, all these difficulties are overcome in this CNC machines. Then again the current market demand. Okay, the market demand is, or this market requires a high quality products. Okay, current market requires a high quality products at lowest cost, as well as in the minimum time. Okay, this time required to produce the component is should be less. Okay, the cost of the product should be low, and with wide range of this variety, and number of varieties are required. This market demands number of varieties. Okay, all this is available, or all this is possible with this CNC system. Okay, answer to above all these problems is CNC system. Okay, all the previously discussed difficulties can be overcome with the help of this computerized numerical control system, CNC machine. Then here fundamental principles. Okay, so these are these fundamental principles or things that we have to know while writing these programs on this CNC machines. Okay, so coordinate systems of the CNC machines, then dimensioning systems, reference system of the CNC machines, that we have to know. Then in this case of this coordinate system or the motion of this workpiece, there are two motions, or longitudinal motion and either longitudinal motion or transverse motion. Then in case of this dimensional system, there are three types or three methods. One, it is called as absolute dimensioning. Second one, it is called as incremental dimensioning, and mixed dimensioning system is there. Okay, either we have to use one of these three, okay, while writing this program. Then reference system, there are two main reference systems in case of the CNC machines. One, it is called as machine reference, okay, which is the fixed from the machine point of view. And second one, it is work reference. Okay, it may vary according to the work or according to the type of the job. Okay, so work reference point with reference point on this work is nothing but this work reference, and this is the fixed or machine reference point on the machine. Okay, so these are the few important basic things that we have to know in this CNC programming. We will discuss in detail. Then types of the CNC machines. Okay, here we can see there are here two types of the CNC machines are shown. One, it is lathe machine, CNC lathe machine, and this is the CNC milling machine. Okay, CNC milling machine. These are the two systems shown here. In these two systems, here in case of the CNC lathe machine, two axes are there, x positive x-axis and negative x-axis. Similarly, positive z-axis and negative z-axis. Okay, this z-axis is along this spindle and x-axis is the transverse to this spindle, okay, or perpendicular to this spindle direction. Okay, but in case of this milling machine, there are three axes, okay, x-axis, y-axis, and vertical axis is vertical motion is there also for this spindle. Okay, and it is represented by this z-axis in case of this milling machine. Okay, but this vertical movement of the spindle is not possible, or vertical movement of the job is not possible in case of this lathe. And basically these CNC lathe machines are used for producing the round components, okay, or circular components, and these milling machines are basically used to produce the flat parts or flat surfaces. Again, the lathes can be programmed on two axes, x and z axis, and this milling machines can be programmed on three axes, x, y, and z axes are used while programming this on these milling machines. Then CNC programming systems. Okay, there are two types of this programming modes, or again we can say this incremental or absolute systems of this CNC systems. Then this incremental and absolute system of this CNC machine is again depends on this reference point. Okay, reference point, incremental and absolute system. We will discuss in detail. So first of all, incremental system. Okay, in incremental programming, the endpoint is specified with reference to the current tool position. Okay, in case of this incremental system, the endpoint of the endpoint is specified with reference to the current position. That means when this, suppose this is the origin of this workpiece, that is 00 or origin reference point of this workpiece, and this is the first point, this is the second point. Okay, when we want to move to this second point from this first point, okay, in case of this incremental systems, the dimension is given with reference to the current position of this tool. Okay, current position of the tool, that means from this position the coordinates of this second point are given. Okay, then for example we can see here, suppose this is the point A and whose coordinates are 0.25, along this Z, and along the X as well as it is 0.25. Okay, so 0.25, 0.25 are the coordinates of this first point. Okay, now while second point it is with reference to this point, that is 0.725 and 0.25. Okay, not from this point, that means 1 and 0.25. So this coordinates of this Second point, in case of this incremental system, from this current position is 0.75 and this 0.25. Then coordinates are specified as u and w. In case of this incremental system, these coordinates are specified by using these letters u and w, where this u is used to indicate the incremental diameter of the part, that is circular part, and w is used to indicate this incremental length of the part. Okay, this incremental length of the part is indicated by w, and incremental diameter of the component is indicated by this u. Okay, this incremental system. Then in case of this absolute system, in this absolute programming, this end point of the motion is programmed with reference to the program 0 point. Okay, suppose this is the origin or work 0 point of this component or workpiece. Okay, and in case of this absolute system, all the points or all the coordinates of all the points are represented from with reference to this origin or work 0 point. Okay, so that means suppose this is the point number 2. Okay, and when we want to move this tool from this point number 1 to point number 2, the coordinates of this point number 1 will be 1 and 0.25. Okay, not 0.75 and 0.25. Okay, that means these coordinates of this point are represented or shown from this origin point, this and this. Okay, in case of this absolute system. Similarly, here it is represented as 1.75 and 0.25. So for this point it is represented as 2.5 and it is 1. Okay, from this point. So in this way, this in this absolute system, these coordinates are shown from this reference to this program 0 point. Okay, then in case of this absolute system, the coordinates are specified by x and z. Okay, x and z. X coordinate is the diameter of the part, and where this z coordinates is the length of the part of. Okay, in case of this absolute systems. Then CNC programming. CNC part program is a set of encoding information, giving a coordinates and other details to indicate how a tool should move on in a relation to a workpiece in a machine should perform desirable operations on the job. Okay, while this performing this desirable operations on this job, okay, this machine should perform this tool path. Okay, or to this tool should move from one point to second point or third point in this way. Okay, this CNC part program is nothing but it is a set of this encoding information which gives this or which functions gives to this tool. Okay, in order to perform this operations on the job. Then CNC program also contains some following basic information while writing this CNC program. So we have to know this few basic informations, that is some preparatory functions are there, or it is also known as z codes. Okay, some miscellaneous functions are also there while in writing this program. Okay, m code, it is represented by m code. Spindle speed is represented by s. Feed rate, it is represented by f. And finally it is tool number, it is represented by t. Okay, we will discuss in detail. So basics in this CNC input data. The first one, it is sequence number. Okay, or it is denoted by this n code. Okay, it is used to identify each block within the CNC program and provides a means by which the CNC commands may be repeatedly located. Okay, that means this n01, n02, n03, n05 are the different number of this are used to indicate the number of the blocks. Okay, or it is used to identify the each block within the CNC program. And in order to perform these operations in the sequence, these n codes are required. These n codes are 3-digit numbers to appear after this n symbol. Okay, for example, we can see here n025 y25 z0 is the one block. Okay, where this n025 is the number of sequence number. Okay, and y and z are the coordinates of this point. Coordinate function. The coordinates of the tooltip are programmed for generating a given component geometry. Okay, in case of this CNC machines, these coordinates of this tooltip are programmed. Okay, these coordinates are specified using these word addresses, that is x, y, z, or we can say u, v, w, or I, J, and K. Okay, these are the letters used to represent these coordinates, and it is used in case of this absolute, incremental, and in case of this arcs in the programming. For example, x is equals to 100.125, y is equals to minus 25.005, z is equals to minus 5.55565. This is the coordinate of a point, okay, represented here. Then third function, it is feed function. Okay, feed rate, displacement, or spindle feed rate is expressed in mm per minute. Okay, feed rate is expressed in mm per minute, and this feed rate is indicated by this letter F. Okay, three-digit number prefixed by a letter F. Okay, for example, we can see here F125. This indicates that this 125 is the feed rate. F is the used to indicate this feed rate, and 125 mm per minute is the feed rate of this machine. Then next one, it is speed function. Okay, the spindle speed is expressed in revolutions per minute, and it is a three-digit number prefixed by a letter S. Okay, letter S is used to indicate this speed function. Okay, for example, we can see here S1000 indicates that this 1000 is the spindle speed. 1000 revolutions per minute RPM is the spindle speed, and S is used to indicate this spindle speed. The next function, it is tool function. Okay, this tool function is used to in conjunction with this miscellaneous function. Okay, for this tool changes, that means M06, or for example we can see here T05 M06, and this means that this is addressing a new tool. Okay, so in case of this T05 M06, this execution of this above statement, this statement ensures that the is numbered new tool number 05 is set up. Okay, so M06 is used to new for new tool, and T05 means the tool number, that is 05 number tool is used or set up. Okay, then few important addresses used in this CNC programs. Okay, so we can see here first one, it is O. Okay, O is used to represent the program number. Okay, initially we have to represent this program number. Okay, for example O123 or O1000. Likewise we have to represent this program number. Okay, this O is used. Then N is used to represent the block number. In the programs there are number of blocks. Okay, so therefore in order to represent the number to this block, okay, this N is specifically used. Then Z are the preparatory functions. Okay, so there are known as preparatory codes, okay, used to prepare the machine for a particular function for that particular machines. So there are preparatory functions are there, Z codes are there, that we have to use in this CNC programs. Then X, Y, Z represents the absolute coordinates of this workpiece. Okay, in case of this absolute coordinate system, these X, Y, Z's are used to represent the coordinates, and U, V, W, and I, J, K are the coordinates used in this incremental coordinate system, and I, J, K used in this center of arc, coordinates used to specify this center of arc. Okay, then R, this R represents the radius of the arc. Okay, radius of the arc. Then S stands to represent this spindle speed. Similarly, T specifies tool number. Okay, M is used to indicate this miscellaneous functions. Okay, so there are few miscellaneous functions are also required in this CNC programming. For example, coolant on off, then spindle on spindle off. Okay, likewise miscellaneous functions are also required. So these M codes are used to represent these miscellaneous functions. Then P and Q. Okay, P and Q are used to represent start and end block number in subroutine cycle. Okay, this P and Q are used to start and end block number to represent this. Then F stands for feed rate. Okay, F represents this feed of the CNC machine. Then interpolation. So there are two types of this interpolation, two methods. One it is linear interpolation and second one it is circular interpolation. Okay, in case of this linear interpolation, this tool is moving in this linear direction only. Okay, in case of this circular interpolation, this tool will move along the circular path. Okay, in the circular direction. Now we can see this in this CNC programming, this linear interpolation is used, Z01 is used to represent this linear interpolation. Okay, the tool is moving in the linear direction only from this point A to point B. Okay, so here for absolute programming from A to B and incremental programming from A to B are shown. Two blocks are shown here. Okay, where this G01 is used in both the cases, it is for linear interpolation, linear movement of the tool. But in case of this circular interpolation, either this tool will move from point A to B or from point B to A. Okay, when this tool is moving from point A to B, it is in clockwise direction. Okay, but when this tool is moving from this point B to this point A, it is in anti-clockwise direction. Okay, so therefore Z02 and Z03 are used to represent this clockwise and anti-clockwise direction of this tool movement respectively. Okay, this Z02 is used to represent the motion from A to B, that is in clockwise, and this when this tool is moving from B to A, that is in anti-clockwise direction, this G03 is used. Okay, so these are the two blocks used to represent this circular interpolation from A to B and B to A. Okay, then codes. The most common codes used when programming CNC machines tools are Z codes. Okay, that is also called as preparatory function, and M codes, that is miscellaneous function. Okay, mostly these Z codes and M codes are used while performing this program. Okay, CNC program. Some other codes are also used, for example F, S, D and T, which represents this feed. Then spindle speed, S stands for spindle speed, D stands for cutter diameter offset, and T stands for this tool number, etc. Okay, these are the few other codes also used in this CNC programs. Okay, so we will discuss few of them here. First of all, preparatory functions, or it is also called as G codes. Okay, it is represented by a two-digit number prefixed by a letter G. Okay, the purpose of this preparatory function is to command the machine tool to perform the functions represented by the selected code number. Okay, for example, G00 is the code used to represent the rapid movement of this tool. Okay, Z00 is used to rapid movement, for rapid movement of the tool. Okay, or again second example we can see here, G90 specifies the absolute input dimensioning. This 95 is used to represent this absolute system. Okay, input dimensioning systems in the program. So we will see few of this Z codes here. Okay, so this G00, here are the few codes, Z codes, and their functions are also represented here. So G00 is used to represent the rapid positioning of the tool, okay, or rapid movement of the tool. Okay, then G01 is used for the linear interpolation. Okay, G01 is used for linear. G02 is used for circular interpolation in clockwise direction, and G03 is used for circular interpolation in counterclockwise direction or in anti-clockwise direction, as we seen earlier. Okay, similarly G20 is used for inch inputs. Okay, when we are providing this input data to this CNC machine in, and it is the dimensions are in inches, then G20 is used. Similarly G21 is used for this metric unit, that is when these dimensions are specified in mm. Okay, in metric units. Then G24 is used for this radius programming. Okay, radius programming. G28 is used to return this reference point, and G29 is used from return from this reference point. Okay, return to this reference point and return from this reference point. G28 and 29 are used. Then G32 is used for this thread cutting. Okay, while when we are going to cut a thread on this a particular job, in that case this G32 code is used for this thread cutting. Then G40 is used for this cutter compensation cancel. G41 and 42 are used for this cutter compensation left and cutter compensation right as well as. Okay. Similarly, this 43 and 44, G43 and 44 are used to represent this tool length compensation in positive and in negative direction. Okay, tool length compensation in positive and negative direction. And G49 is used for tool length compensation cancel. Okay, in order to cancel this tool length compensation, G49 is used. Then G84 is used for Canada turning cycle. Okay, to represent this can turning cycle, G84 is used. Then G90 is used for this absolute programming, and G91 is used for this incremental programming. Okay, absolute dimensioning and incremental dimensioning, this G90 and G91 are used. Okay, so these are the few preparatory function codes, G codes. Now miscellaneous functions. Okay, these functions, these miscellaneous functions involves actions that are necessary for machining. Okay, for example, spindle on or off, then coolant on or coolant off. Okay, these are the few miscellaneous functions related with this CNC machining. Okay, and these miscellaneous codes are M codes are used for this miscellaneous functions. Then these are used to designate a particular mode of the operation of the CNC machine tool. Okay, these M codes or miscellaneous function codes are used to designate a particular mode of the operation of the CNC machine tool. Then program number. Okay, so the symbol used to for this program number is O, or sometimes it is used by this symbol. Okay, followed by this, followed by its number. Okay, for example, here we can say O123. Okay, is the program number. 123 is the program number, followed by this letter O. And similarly, also we can write this program number as this symbol 123. Okay, in this way also. This program number does not interfere with the execution of the CNC program. Okay. So as this, in case of this computerized numerical control machine, this computer is used to store number of programs. Okay, so therefore this interference of this program is possible. So this program number is used to avoid this interference of this execution of the CNC program. Okay, now some miscellaneous function codes, M codes. Okay, so we can see here M00 is used to represent this program stop. Okay, our comma starts again when cycle starts is pressed. When we start a cycle start button, then this program again starts. Okay, this then M01 is original, sorry, optional stop. M01 is optional stop. M02 is used to represent the program reset. Okay, the program reset and rewind. M30 is used. Then M03 is used. M03 and 04 are used for spindle start in clockwise and in anti-clockwise direction. Okay, when the spindle starts in clockwise direction, M03 is used. When it is rotated in anti-clockwise or counterclockwise direction, this M04 is used. Then M05 is used to represent this spindle stop. Okay, spindle stop. M06 is used for this command tool change when we want to change the tool. Okay, or in case of the CNC machine, the number of we can mount number of tools on this turret. Okay, multi tool changing turret. So therefore this tool change M06 is used to change this tool. M07 and 02 08 are used for this coolant on. Okay, similarly M09 is used for this coolant off. Okay. M10 and M11 are used for open the chuck and close the chuck. Then M13 and 14 are used for this spindle on and coolant on simultaneously on clockwise direction as well as in anti-clockwise direction. Okay, M13 and M14 are respectively used. Then M25 and M26 are used for tailstock wheel extend and tailstock wheel retract. Okay, this extend and retract is represented by this M25 and M26. Then M98 is used for this to represent this sub program call. Okay, when we want to call a subprogram or some short other program in this program, then M98 is used, and M99 is used to return to this main program. Okay, when we want to return to this main program again, then we can use this M99 code. Okay, so these are these few M codes used in the CNC programs. Okay, then one more important term that is required while studying these CNC programs is tool offset. Okay, the distance traveled by this tool cutting edge from the machine reference point to the work reference point in a particular axis is termed as a tool offset. Okay, for example, this is the tool which is mounted on this turret, and this is the workpiece mounted on this chuck. Okay, now we can say this is the work reference point. Okay, work reference point, and this is the tool reference point, or again we can say the machine reference point. Okay, the machine reference point, then this distance traveled by this tool, okay, from this machine reference point to this work reference point, this is called as offset, tool offset. Okay, now here this horizontal distance of between this tool machine reference point and this work reference point is the z offset, and this vertical distance is called as the x offset. Okay, x offset. Then for turning tool offset, it is measured in both the direction x and z as represented here, x offset and z offset. Okay, this is the tool offset. Now in this lecture we discussed about this various functions that required while representing this CNC programs. Okay, friends, thanks for watching this video. If you like this video, please share, comment and like this video. Then subscribe to my YouTube channel and click on the bell icon to get notified for more videos on this CAD/CAM subject. And thanks for watching. Thank you so much.